I already worked out a few kinks last period. So, okay, before I forget, dual credit. The assignment that's on your desk is due Wednesday. So the assignment itself is due Wednesday. The table that I gave y'all, that's due on, or wait, sorry, the table is a table. It's the formula chart type. So forget it. The table is a resource. You can use it like a formula chart, meaning you can use it on your test on Friday. As long as you don't write anything on it, you can use it. Speaking of tests, I posted the review in Blackboard for y'all for dual credit. I was just saying that the assignment's due Wednesday.
This one?
Yes.
All right.
Because it's the last assignment for test 2 material.
Okay. And we didn't need anything due Monday, right? All right.
As long as you got done with the weekend assignment, you're good.
Yeah, the one that'll be Friday.
Okay, so for dual credit, your review is posted in Blackboard. I'll put it in Blackboard. If you saw the email I sent out, I'll set it in the email. I'll say it again. Study your homework. I looked at the test this weekend. I even added a bonus question to the test worth 8 points. It all comes pretty much directly from the homework, for the most part. Even the matching vocabulary, you hit on it in the homework. So study the homework.
You said not to write on this thing, right? Binomial.
Yeah, don't write on the binomial chart.
All right.
I mean, what's that? Homework's due on Wednesday. Yes. That'll be the last homework that has test 2 material. You're actually going to get another assignment tomorrow. That's going to be test 3 material, but it won't be due until after y'all take test 2. It's going to be another one of those weekend type homeworks where I'm going to give you the whole weekend to work on it.
Okay, thank you.
So I'll give it to you tomorrow, and then you'll have all the way through Sunday night to do it. So we'll worry about that tomorrow. Let's get through as much of today's material as we can. Last period, I didn't get near as far as I wanted, so we're about a page behind. We were a page behind Friday when we stopped, or when we started. We ended a page behind, and then last period, I ended a page behind. So that's okay. We'll get caught up eventually. I mean, what's the worst thing that could happen? I moved the test to Monday.
Yeah.
Then you get more time to study. But then that means your test will be closer together for the next test. Okay, and that means you'd have to spend the weekend studying for a test.
Yeah.
Anyways, we're going to start where we left off on Friday. So, before the weekend, we were talking about, if I can get this thing to click. Before this weekend hit, or last weekend hit, we were talking about linear combinations and finding the mean and variance and standard deviation for a linear combination of variables. So we had this constant A1 times variable 1, A2 times variable 2, and so on. The mean played nice. We just A1 times the mean of 1, A2 times the mean of 2, and so on. to get the standard deviation, though, we had to get a little creative. We had to square the A's and then multiply them by the variance for each variable. And take the square root of that whole thing. So that's what we ended the day Friday doing.
We need to write this down, though.
If you wrote it down Friday, you don't have to. This is on page 11.
Page 11? Okay. Oh, yeah, I wasn't here. I got it.
Yeah. If you wrote this down on page 11, you're good. If not, you may want to write it down right quick. I will say, dual credit, you won't be responsible for this on the test.
Oh, really? Not gonna be on the sheet, or?
It won't even be on the sheet. Like
Oh,
you
so
don't
this is
even,
not the test.
this isn't on the test.
Okay.
That's what I said, that's what I was saying, study your homework.
What about, the stuff we covered yesterday, or not yesterday, Friday? How much of that, like, after I left, I mean?
The stuff after you left, not much of it really is going to be on the test.
All right. Let's make sure.
Not a ton. Essentially, if you didn't do something like this, like it on your homework, it will be tested on. So we're going to look at the serial example, which is at the top of page 12. Now let's suppose a 1 pound box of sugar treat cereal has a weight distribution with a mean of 1.050 pounds and a standard deviation of 0.051 pounds. And a 1 pound box of sour balls. That doesn't even sound good for a cereal name. Have a weight distribution with a mean of 0.109 and a standard deviation of 0.087. If a promotion is held where the customer is sold a shrink wrap package containing 1 pound boxes of both types of cereal, what's the mean and standard deviation for the distribution of promotional packages? So that's our problem. Let's actually start working it. So they went on and pulled the mean out of the problems for us. Let's also pull out something else they gave us, the standard deviation. So let's say sigma t would be what? What did they tell us sigma t was? Point 0.051. Let's just make note of that here. And then sigma b is what? 0.087 pounds. Okay, so now we need to figure out the mean of the combined package. So here, how many boxes of each are we putting in the package? Just one box of each. Remember, means play nice, so we can just add them together. So 1.05 plus 1.090, or I don't even need that O right there. 1.05 and 1.09. What would that be equal to then? 2.14 pounds. There's our new mean. Now we need to get the standard deviation. But to do that, let's find the variance. So the variance of our package. So the formula says that we would need like an A1 squared sigma 1 squared plus A2 squared sigma 2 squared. But on these A's, how many boxes of each did we say we're putting in there? One. So these A's are really just ones. So our 1 and our 2 should actually be T and B. So I would do 0.051 squared plus 0.087 squared. And this gets me my variance for the packages. So what would that equal when we add those together? Let's give the full decimal. I think it's only goes to 5 decimal places.
Zero one zero one.
0.01017. Good. Now they ask us not for variance, but for standard deviation. So how do I get standard deviation? Square root it. I'm going to take the square root of 0.01017. What would that give us?
1008.
Yeah. 0.100. We're just going to leave it at 8. 0.1008. And our units here would be pounds. This should be pounds squared.
Mr. Schultz,
Yes.
why did you cross off the A1 and A2 squared in the top?
Because these A's, since we're just putting one box in there, they're really just a 1. So what's 1 squared? 1.
Okay.
It really wouldn't, in this case, it wouldn't really change the problem any.
Okay, so like up in the problem, it says that there's only one box.
Yeah.
Okay.
It says we're shrink wrapping a box of sugar treats and a box of sour balls together. Yep. Any more questions on this one? Okay, then let's look at, on this first, let's pull up the solution. No, that wasn't supposed to happen. I got rid of that, I thought. I guess I didn't. Anyways, the solution, if you could have seen it behind it, it says the same thing. But you can't see it because of all my text. Lovely. Okay, let's look at the fruit example. So a distributor of fruit baskets is going to put 4 apples, 6 oranges, and 2 bunches of grapes in his small gift basket. The weight in ounces of these items are the random variables x1, x2, and x3 respectively, with mean and standard deviations as given in the following table. So apples are x1, oranges are x2, grapes are x3. Find the mean, variance, and standard deviation of the random variable y, where y is the weight of fruit in a small gift basket. Okay, so so there's our table. We're going to assume that the weights of the different types of fruit are independent. In other words, we're not going to say they came from the same tree, same vine. We don't know where they came from. We're just reaching in and grabbing apples. Reaching in and grabbing oranges and grapes. Okay, so how many apples did they say they're going to put in a basket? 4. So under here, I'm going to make a note that A1 equals 4 because we're putting 4 apples in there. How many oranges? So I'm going to say A2 is equal to 6. And how many grapes? 2 bunches? Or 3? 2. Okay. And I just randomly followed the duck song. I think that's what it's called, the duck song. Have any grapes? Okay, so let's then find the mean first. So the mean of y, if we write down our formula, that would be A1 times the mean of 1 plus A2 times the mean of 2 plus A3 times the mean of 3. We said our A's were down here below, so we would have to do 4 times the mean for apples, which is 8, plus 6 times the mean for oranges, which is 10. Why does it keep doing this? plus 2 times the mean for grapes, which is 7. If we multiply and add all of these up, what do we get for the mean weight of the basket? $106. What units am I in? Ounces, good. Okay, then I need to get the standard deviation, or first let's do the variance of y. So that one, that's where I do A1 squared sigma 1 squared plus, why did it keep doing this? A2 squared sigma 2 squared plus A3 squared sigma 3 squared. Well, let's see, A1 is 4, so we're going to have to do 4 squared times 0.9 squared plus 6 squared times 1. What is going on? Plus 2 squared one of these days they'll let me write it without doing those crazy lines. Times, looks like my standard deviation is 2. Okay. So if I put all of that in the calculator, what would it give me for my new variance? What's that? That sounds a little high.
72.52.
72.52. And we're going to be in ounces squared. Now, we want to find the standard deviation. So to get that, what do I have to do? Square root it. when you square root it, what do you get? Yeah, let's do the 2 decimal places. 8.52. And we're going to be in ounces. So those are the 3 things it asks for. Okay, questions on this one? Okay, so can't see it behind my text, but there's the full solution. So 7.5. Now we are where we're supposed to be today. Just about 30 minutes late. So 7.5, we're doing the binomial and geometric distribution. Now, here's what I'll say. Dual credit, you're only responsible for the binomial distribution. So, we're probably not going to finish it today, but still, that's the part you're responsible for. AP, yeah, I know all of it, sorry. Okay, first, let's look at a few special distributions in general. And you don't have to write this down. This is just kind of giving you an overview of what we're going to look at. So there's 2 discrete distributions that have a name that we're interested in. The binomial distribution and the geometric distribution. And then one continuous, it's the normal distribution. There's tons of distributions, both discrete and continuous. We're not going to worry about those. We're just going to focus on the 2 discrete up there and the 1 continuous. So let's suppose we go to CHI St. Luke's and we're going to record the gender of the next 25 newborns at a particular hospital. So we're doing it at CHI. Some questions we may say are, okay, well, what's the chance that at least 15 are female? Maybe we're recording them, but maybe it's because, I don't know, we made goodie bags or something. Who knows? So, the chance that at least 15 are female. Maybe we made 16 bags. And we're like, oh gosh, I don't know if I made enough. I don't want to have a bunch of extra left over. What's the chance that between 10 and 15 are female? Out of 25 newborns, how many can we expect to be female? These are all questions that can be answered using a binomial distribution. So let's look at the properties of a binomial. First, we have to have a fixed number of trials. This can't go on forever. There can be a bunch of trials, but it can't go on forever. So we're going to use n to denote the fixed number of trials. N is our total trials. Second thing we have to have is that each trial can only result in one of 2 mutually exclusive outcomes. And we're going to call those a success or a failure. So if we go back to our newborns example, if we're interested in females, then females would be a success, males would be a failure. The outcomes of each trial are independent. And the probability that a trial results in a success is the same for all trials. The probabilities cannot change. So those are our 4 properties that we have to have in order for it to be a binomial experiment. If we fail to have any one of these, then it's not binomial. So in these experiments, we're going to say X is the number of successes when an experiment is performed. So if you want the probability of 2 females, then X would equal 2. If female is what you're calling a success. Okay, so I realize we don't quite have an even number in here to do this. So for a second, I need to put this, I wanted to put y'all in 2 groups, which I could. Justine and Brandon, I may get y'all to work with Riley. And then, or y'all 3 can work together, and y'all 3, however y'all want to do it. Do y'all have a preference? Because I'm about to assign a problem. I know y'all 2 are going to want to be together. I knew that much. So I guess it's up to the guys. Do you want to join them, Riley? Or? Why don't we do that? Why don't you join the 2 girls? And then that way those 3 can stay together. And then that way y'all can just talk along the back road, basically.
Alright.
Okay, so y'all are a group. Y'all are a group. AP, as usual, y'all are a group. Okay, so for the next 3 little problems, I want y'all to determine if they're a binomial distribution. If they're not, then try to tell me why they're not. So, Justine, I want your group to do number 1. AP, I want y'all to do number 2. Riley, I want your group to do number 3. So 1, 2, 3. I'm going to give you about a minute and a half. Read it and then try to see if they are a binomial distribution.
Red cards, there's either red or black ones, so that's your 2 usually.
What? No, because they're, there's only 2 colors.
Yeah.
There's only red and black.
There are 4 different groups, but they're red.
What are y'all thinking?
She don't know.
Mr. Phillips, with the 1 hour period, does that count as a fixed number?
I guess the only way is.
So the actual subjects would be your 6. The number, so your trials would be like how many people you're
I
observing.
guess it could be. not independent.
So,
since
on
they have a
yours,
certain amount of-
There's no,
is there a set number of people?
just over 112. Going back down to the truck.
I'm not trying to.
Right.
I can't, I don't wanna say too much more without giving it totally away.
I think so.
That was just kinda hint, that was just hint.
It's pretty much a room, they count people under 12 or not.
Are you listening?
Oh, the probability,
I'm just saying,
Say that.
Fine.
So how do you know if they're independent?
Just one, but yeah.
Oh.
trial result, the outcome would be. Yeah. And the probability.
Is it your birthday?
It is.
Today?
Yep,
Happy birthday.
Happy birthday.
Have a good day, show.
thank you,
Oh, it's your birthday? Oh, happy birthday.
thank you.
I thought you was like, you happy birthday. Oh, why didn't you tell us?
Where did you look? Oh,
He did, it's on the board. It's just little. Oh.
It's not good.
Are we being good for you?
You know what?
I can't see it.
I did it, guys.
It's right over there. It's a small.
Yeah, it's little.
Oh, okay.
You sure you got your glasses?
What are you gonna do? After school?
I'm all right.
Well, if I can get out of here early enough, probably go get a haircut. Living it up with a haircut.
Are you gonna do anything?
I always feel great after a haircut, so.
Probably not. Go home and do more work.
No. It doesn't sound hard.
I'm just trying to stay caught up.
You know, we would have been okay with just giving you the day off today.
I tried to say, hey guys, can I just take off work? And like, no, sorry. Oh, darn, I tried.
You could have just chilled in here. No.
No. Okay, so group one, what do y'all think? Is that a binomial?
I think.
It is. Yep. We're tossing a coin and counting how many heads. So yes, it would be binomial. Group two.
Yeah.
You don't think it is? Actually not.
What is because the probability is on
Probability does not remain constant. We're dealing 10 cards. So since we're dealing them, we're not putting them back. We're giving you 10 cards. That's right. It's not independent. So that would count.
And more than two outcomes, right?
No, there wouldn't be more than two because what two colors are in the deck of cards? Red and black. There can only be red and black cards.
They didn't say anything about black cards, so.
Oh, but it's saying you want to count the number of red. There's only two colors in the deck, red or
The other color.
the other color.
Okay.
Yeah. So since we're not putting the cards back, the probability changes, which means they're not independent. And then group three.
You said no.
So why did I say that? Y'all were right.
Because there's not a fixed number. Because it's just the kids under 12.
That's actually the exact reason. No fixed number. Now you said kids under 12.
That's not fixed, because there's a lot. Like if it was fixed, it'd say like how many of the kids, right?
That's right.
Like, like hypothetically, could it become a fixed number if they like mentioned how many kids there were under 12? Or,
Well, if they said that instead of in a 1 hour period, they would have said in the next 50 customers or something, then it would be binomial. But they just said 1 hour. Well, you could have in a really bad hour no customers. In a good hour, who knows how many you could have. I mean, if it's like Christmas and a new movie just came out, a big box office movie, you could be running around like a chicken with your head cut off. So, and we'll actually, I misspoke last period, but this is actually, this last one is a geometric distribution. So, yeah, we'll learn about geometric. I actually take that back, it's not geometric. So I'll start, never mind. It's not geometric, it's what's called a Poisson. Which y'all have to know that. No one's gotta know it. AP, dual credit, no one's gotta know it. But it's called the Poisson distribution. It deals with, the Poisson deals with time periods. How many you expect to observe in a certain time period. That's the Poisson distribution. In college, we joke and call it the bad distribution because it's spelled like the word poison, but with 2 S's. Like, oh, you mean the bad one? Yeah, the bad one. Okay, so let's look at the binomial probability formula. So the actual formula itself is just one of these. It's not this whole thing. Let me show all of them. So N is the number of trials. P is the probability of a success. So this is what you'd write at the bottom of page 13. Now, this, I believe, if it's given, I'm not sure if it is or not, but if it's given, this first one's probably what would be on the AP formula chart. If it's even there.
that's what we write this.
So, I want to say the second one right here is on y'all's formula chart. So what it's saying, the way you read this is N choose N choose X, sorry, not K. N choose X, meaning we have 12 trials, and let's say we want the probability that 5 are a success. So then we would say 12 choose 5, because we want 5 successes, times the probability that something is a success to the number of successes, times the probability that something's a failure to the number of failures. Now, this, if you'll notice, dual credit, this isn't anything new. We've dealt with combinations before in 3.4. AP, this is a combination if you don't remember it from geometry. Right now, the formula probably looks like a bunch of madness, but by the end of today, hopefully it makes more sense. So, anyone still trying to write it down? No? Okay, let's jump into an example. So, for reference, for dual credit, I just gave y'all some tables. AP, these tables are not in your formula chart, but if you wanted to use them, they're in the textbook. Binomial tables are in the textbook on table 9. But they won't be in your AP formula chart, so I wouldn't become too reliant on them. I wouldn't rely on something I can't have. Also, technologies such as calculators and statistical software will be able to perform the calculations. I haven't looked much into the inspires, but I can't help but think there's probably a binomial function on the inspire. There actually is. So, AP, if you're wondering, for binomials, you can go to menu, probability, and then distributions. And then at the bottom, you'll see the binomial. And what we'll be dealing with mainly is the binomial PDF. On the 84s, I don't think it has, it may have the binomial PDF in there. I haven't checked. If you look in catalog, it may be there. So on the AP test, I would probably be using that binomial deal in my calculator instead of spending time typing that whole big formula in. Which really it's not, I say big, it's not that big. Let's be honest, it's a pretty small formula to type in. It just looks intimidating. Okay. So let's, instead of recording the gender of the next 25 newborns, let's record the gender of the next 5 newborns at the hospital. So would this be considered a binomial experiment if we're recording gender? Yes. We're not going to deal with multiple births, so twins, triplets, quadruplets, quintuplets. I feel sorry for them. To have 5 babies at the same time.
Oh, okay. Yeah, that's the problem.
I mean, a friend of mine has 3 under the age of 30. I'm like, oh, good grief. I bet y'all's house is crazy on a daily basis. So let's define our variable of interest. So what are we wanting to look at? Let's say X is the number of females born out of the next 5. So everything in red up here is a blank on your notes if you want to, if you're filling the notes in. If not, then okay. So X is the number of females born out of the next 5. So what are our possible values of X?
0 through 5?
0 through 5, good. We could have all males, or we could have all females. 0 through 5. So let me ask you this. Will a binomial random variable always include the value 0?
Yes.
Yes, it will. And here, think of it this way. So let's not even think about the baby's example. Let's think about flipping a coin. Is it possible to sit there and flip and get no heads if you flip it 5 times? Yes. I'm not asking is it likely, I'm asking is it possible? Yes. So it's possible to have no successes each time. What will our largest value for a binomial random variable be? So just in general, what would it be? The number of trials. So in general, we're going to go from 0 to the however many trials we have. If it's 1,000, we'll go from 0 to 1,000. If it's 30, we go from 0 to 30. Okay, so in our example here, what's the probability of success? And remember, we defined a success as being female. The female is born. So what's the probability of success in this case? What was that? 1/2. Perfect. Okay, so now that we know our probability of success, let's find the probability that exactly 2 girls will be born out of the next 5 births. We want exactly 2 girls. Okay, so that means what we're asked to find is the probability that x equals 2. Now, a couple of things we need before we get started. We need to know n. N is 5. We're only looking at 5 births. We need to know p, our probability of success. 1/2. I'm going to put it as 0.5. Okay, so our formula says that we want x equal to 2, so we're going to have 5 choose 2 times our probability of success. How many successes do we want? 2. That's what we're going to put as our first exponent. What's our probability of failure? In this case, also 0.5. They won't always be the same. To the 5 minus 2 power. Because that's how many failures we'll have. So if you put this in the calculator, you would put this as, I'm going to write it in terms of like putting it in the 84. 5, choose 2, times 0.5 squared. Now what's 5 minus 2? 3. So let's just save ourselves a couple of keys and just say 3. That's how you put it in the calculator. Now on the Inspires, to get combination up, you'll do menu, probability, combination. That's on the inspires. Menu, probability, combination. And then when it pops up, it'll say NCR with the parentheses. In the parentheses, you'll put N, comma, R. So 5, comma, 2. For doing the inspire. And once someone calculates it, let me know what you get. Okay, what did y'all get? Hopefully someone's got it. 0.3125, good. Yes.
Okay, TI-84.
On the TI-4, to get, first we'll have to do the combination. Let's open up a parentheses. And then you'll need to go to math. Over to probability. And then look for combination, NCR. Oh, sorry, in front of the NCR, we should have hit a 5. So you'll want to look exactly like it does up there in that bottom row. Okay, now, dual credit. We haven't really talked much about it, so let's pull this table out that I gave you. I want y'all to get familiar with this table. It can help you in some cases. It can't help you in every case, but it can help you in some. Okay, so here's how we use this table. What we want to do is look in the very left column for our n. So what's our n in this problem?
2, right?
That's our x.
5.
5. Okay, so I'm going to look in the left, very far left column, go down until I see 5. And then notice it starts counting 0, 1, 2, 3, 4, 5.
Mm-hmm.
Those are your x values that you can have.
That's a 2, that's a 2.
So then we want x equals 2. So we're down here on our 5. We go over to where x is 2. That's that second column. And then what's our probability of success? 0.5. Those are across the top. So if I'm 0.5, and then go down until you get to the row that your 2 is on. 0.312. That would be your probability of 3 decimal places.
Wait a second.
Yes, ma'am.
0.312?
Even if you don't put the 5,
So I actually was that rounded, Nate, or was that the exact?
I think it's 22.
I think it's exact, yeah.
The exact? Well, the table's off. So I found in some cases where they're off just a tiny smidge. So like for the purpose of the test and homework, you can use the table. If they have, so here's the catch with the table. Notice, does it have every single probability on top? Does it have like 0.32? No. So on those, you can't use those. You gotta use your formula. So if it has one of these, you can use it. I can use it.
And we'll point out the other way. Oh, I'm supposed to go here? No, I was looking.
So that's your point five.
Okay, I got you.
Go down where 2 is.
Okay, I was reading the point twelve.
Oh, you wanna go. And if you look on this chart, notice it goes from n is 2 all the way, ultimately, it starts skipping some, but ultimately it'll go to n equals 20. So it goes 2 through 12, just 2 through 12 period. 2, 3, 4, 5, 6, all the way to 12. Then it skips to 15, then 16, and then it skips to 20. So, anyways, that's how you read this table. Okay, so is there any questions on reading the table or this example? No. Okay, on to the next then. So this is, wait, go back. Okay, now, let's find the probability that less than 2 girls will be born out of the next 5 births.
Oh, I got you.
So if it's less than 2 girls,
It's 0 or 1.
0 or 1, that's right. So I'm going to put that into symbols, that way we get used to seeing that. Probability that x is less than 2 is the probability that x is 0 plus the probability that x is 1. Now, this is in the notes, if you didn't find it, this is down below where it says x and p of x. The notes are slightly out of order. So it's about the halfway, just below that second hole punch. Okay. So let's set it up using the formula. So we're going to have 5 choose 0. The probability of success is 0.5. How many successes will we have? 0. Times the probability of failures. How many failures will we have if we have no successes? 5. Plus, then we want the probability of 1 success. So 5 choose 1 times the probability of success to the number that we have times the probability of failure to the number of failures we have.
Is that 0.5 to the 0 number?
Yes.
Okay. And then the first time?
Yep. Usually they're not going to be the same. They're not both going to be 0.5. I'll say usually. In most cases. This is just a special case because we're saying boys and girls are equally likely.
And what are the powers for those, like 0, 5, 1, 4? Like, why are they what they are?
Or are they what they are? So, if we think about back when we did independence,
Mm-hmm.
we said, okay, well, each trial is independent, right? So, to get the probability that they're certain thing, you would just multiply all the probabilities together. So, if we had 2 successes, I'm going to just kind of illustrate that down here. Let's say a success was 0.6 instead of 0.5. We said, okay, well, I want 1 success. I just want 1 success, period. So, let's say my first one's it's not going to let me do it down here. And you don't have to write this part down here at the bottom down. But let's say our first one's a success. I'm going to just do 3 trials to keep it simple. So that's a probability that one's a success, right? The first one is. But then I also have, well, the first could be a failure, but the second could be a success. Well, that also means I can have the third be a success, but the first 2 failures. So if n was equal to 3 and x equal to 1, there's 3 different ways I could get a success out of that, right?
Mm-hmm.
Well, that's where the 3 choose 1 comes from. Okay. That gives me how many ways I can have that outcome. 3. Then, what's my probability of success? 0.6. That's what we said. I should have put that here. Well, how many?
That's a given, right?
Yeah.
Okay.
How many successes did I have in each of these?
3 or 1.
1 success. So if I just look at this first one, for instance, I only had 1 success, right? So 0.6 to the first power.
Mm-hmm.
What about the second one, or the failures? How many failures did I have?
2.
2. So would you agree that that's the same as saying 0.5 times 0.5?
Mm-hmm.
Well, doesn't this formula look like that formula?
No.
Other than probabilities, like just the style of it.
Yeah.
Yeah. That's how we got the binomial formula. We just didn't derive it. I thought we just said, okay, here it is. But that's like how you would derive it. Does it make a little bit more sense now?
Yeah, I got it a little bit. I'm gonna just look at how you do the rest of it and I'll figure it out.
Okay. In AP, if you were paying attention, you're probably thinking, didn't we have a homework that did something like this? A homework problem? The answer to that would be yes, you did.
Is this gonna be on my test?
The binomial distribution, yes. You'll have to work one pretty similar to this, actually. Okay, so if we type this in the calculator, what would we get? What would the probability be? .1875, good. Questions on this one? Okay. This is just the worked out solution that was typed up and already in the PowerPoint. In case you want to reference it, it's also the one that you'll see in the PowerPoint uploaded online. Okay, let's construct the discrete probability distribution for this binomial random variable. So they gave it to us, but what they essentially did was they just plugged in x equals 0, x equals 1, x equals 2, and did all the calculations for each. Notice this x equals 2 is the same exact thing that we got when we said x equals 2. So that's where you put, where you have you see the x and then p of x on your notes. This is for the table. And the reason we did this is we want to figure out what's the average number of girls born in the next 5 births. Using our table here. Well, let me ask you this. What kind of distribution is this? It's not normal. Nope. Nope. Is it discrete or continuous? It's discrete. Yeah, that's right. Normal is its own distribution. It is symmetric, yes. So since this is a discrete distribution, to find the mean or average, simply multiply x times the probability of x. So 0 times, we know 3.125, plus 1 times 0.15625, plus, and so on. So you ultimately end up with, if you multiplied it all out, you'd end up with 2.5. It's almost like what? Yeah. I mean, it's almost like I just took the number of trials and times it by a half. Interesting. So that's actually what it says next. Notice this is the same as multiplying n times p.
We're not finding anything different with this, right? This one, like we've done this before.
We've done this before, yeah.
All right.
You guys will?
Yes.
Okay. So let's look at another example. Let's say the adult population of a large urban area is 60% African American. If a jury of 12 is randomly selected from the adults in the area What's the probability that precisely 7 jurors are African American? Precisely 7. So let's figure out what all this is. So what's this 12 represent? A jury of 12. What's that represent? That's our N. What about this 60% right here? That's our P. And then what's 1 minus P equal to? 0.30?
0.34.
Whoa, what just happened? Okay, I'll write it again.
So what does N mean again? Like what is the
N is the number of trials.
number of trials? Okay.
P is the probability of success. And then 1 minus P
Is the probability of failure?
is the probability of failure. Okay, so they ask us the probability that we get precisely 7. So 12 choose 7. I don't know why it does this. Okay, what's our probability of success? 0.6. And how many successes do we want? 7. Times the probability of failure. How many failures will we have? If we have 7 successes. 5 failures. Let's just make a little note over here just to make it official. Hey, this is already aggravating me and it's brand new.
Oh, I get what the number is. So
Exponents should add to equal n. I'm not going to do that because that looks like I'm saying n factorial. Okay, so if you calculate this, what would you get? 0.0539? Anyone else get anything different?
0.2270.
That's what I got too.
and the 12 gives 7, that's the 12 NCR 7 now.
Yes.
What always be NCR?
For binomial distribution, yes. Questions on this one?
Oh, is that it?
That's it. That's it on that one. Yep, that's it. Can you wait like 5 minutes? Okay, 'cause that's all we have in class is 5 minutes.
We're about to do this next one.
So I'm actually going to go and give 2 formulas. That way y'all have enough to do your homework. And then hopefully we'll go back and have time to catch this next one. Okay, so real quick, just so you have the formulas. Okay, so flip over to page 15 for a second for me, please. Okay, to get the mean of a binomial distribution, you do n times p, where n and p are just like we've been doing all along. N times p. For the standard deviation, you do n times p times 1 minus p, and then take the square root of it.
What page is this again? 15?
Yep. 15, right under where it says formulas for mean and standard deviation. Now, one thing I'll say for dual credit, and just in general, this value right here is also known as Q. So if that's the standard deviation, the variance can be written as NPQ. Okay. I don't think we're going to have time to get that last one all the way. And we got 4 minutes. As it was. Yeah. Are y'all okay with having 2 assignments due Wednesday?
I'd rather know all of both assignments have been disseminated and not know one.
Okay, fine. So AP, I'll give y'all until Wednesday to get this one turned in. But then that means Wednesday you'll have 2 assignments due.
Mr. Schultz?
Yes.
Yeah.
Yes, you may. So there's one example technically behind third period, but we'll all get caught up eventually. Have a good one. Today? I got E. Let me check. I'm hoping I hit record. Which is not me.
To be honest, I just want to get it done over with today.
I'm hoping I hit record.